Hi everyone, welcome back to the video tutorial series for Breedcow Lite. This is the second introductory video where we're going to dive deeper into the economic analysis. We're going to look at some management strategies, specifically selling our preg-tested empty cows, analyse feeding phosphorus in the wet season, and also a destocking break-even analysis. We're going to go through these scenarios quickly, so please use this video as a resource which you can come back to. Pause and replay each relevant section as needed. Our first management strategy is selling our unproductive breeders. We're going to start by looking at our results from selling 0, selling all of them, and then selling our maximum to maintain a steady state herd. This is an important strategic decision for graziers as it can affect gross margins, production efficiency, and the herd performance. So we're going to jump straight into a new Breedcow Lite file. If you're looking for how to set up and get to here, please refer back to the quick overview in tutorial 1. The wiki available in the Help tab also defines terms such as steady state herd and adult equivalents, which I'll be referring to in this video. We're going to start in the input section, and let's start with low productivity figures and then adjust them for our property. So first thing we're going to look at is our preg-tested empty sales. We're going to start by selling 0%. So let's assume that we're not preg testing, so we're not in a position to sell any empties because we don't know. We're going to keep them all as replacement heifers. Calf loss. Technically, if we aren't preg testing, we won't know what our calf loss percentage is either. But for this scenario, we're just going to keep our low productivity example of 20%. Our wet season supplementation, we're going to start with $0 as we're going to look at that later in the video. And our long-term carrying capacity, we're going to change that to 1200. Press calculate. Now you can see there that our current baseline farm with no PTE sales has a gross margin of $81 per adult equivalent after interest. We're producing 79 kilos of beef per adult equivalent, and our reproductive efficiency, the weaning rate, is 50%. Now let's go back to our input section and assume we're now preg testing, so we can change our preg tested empty sales to 100%. Let's try to sell them all and see if we can still have a steady state herd. Press calculate. Now you can see there that we've got an error message. That means our steady state herd has not been achieved and we can't rely on these calculated results. Under these conditions, there's not enough replacement heifers to breed to create a self-sustaining herd, which means our herd numbers are reducing over the long term. This has caused the error in our calculations. You can see here that we've got a negative total excess heifers sold. You can see if you hover over the error, there are some suggested fixes, primarily by adjusting your PTE sales. Otherwise, you can check conception, calf loss, or mortality, because currently they are not high enough to generate long-term replacements. To correct this error for our example, we're going to look at adjusting our PTE sales. So we want to sell as many unproductive cows as we can while maintaining a steady state herd. Now we could work through trial and error to find the exact percentage to maximize our PTE sales, but I will save you watching me do that. And the max PTE sales we can make while maintaining our steady state herd is 51%. This is the max under this combination of inputs, but it will change for every scenario, which you will see later in this video. So let's see what that does to our results. So this has resulted in a steady state herd. However, we've also maximized our sales of unproductive cows. When comparing to scenario 1, where we didn't sell any preg-tested empty cows, we're now making an extra $11 gross margin per adult equivalent. Our gross margin for the herd has increased by $13,500 after interest, and we're producing beef more efficiently with an improvement of 7 kilos per adult equivalent. Now we're going to continue on by analysing our second management strategy, feeding wet season phosphorus. We're going to compare a no supplementation example to a $15 per head example. Then we will do a break even to determine the max cost we could pay with our assumed improvements. Again, this is an important decision for graziers to analyse, as by utilising effective supplementation, livestock performance and profit can be improved depending on their deficiency level. We're assuming that this scenario is on land that is acutely deficient in phosphorus, which just means we will see bigger cattle production results when we address the deficiency. So we're going to start by bumping up our average live weight gain by 30 kilos to 120. Our preg test rate, our conception rate, we're going to bump up by 10% to 77. PTE sales, we need to maximise again using this new information. This is a new scenario. I've trialled this previously, and under this supplementation scenario, we can sell 100% while maintaining a steady state herd. So we will maximise that there. Our calf loss percentage, we're going to drop that by 5%. Breeder mortality, we will halve that. Now we're going to leave all our ages and our input costs except for the specific wet season P1 here. We're now going to feed that out at $15 per head per year. Press calculate. Now let's compare scenario 3 and scenario 4. This is before and after wet season P supplementation. Our variable costs have increased by $11,700. However, our gross margin per AE and for the herd have both increased to outweigh this increased cost. The per adult equivalent has gone up by $87 and it's $104,800 for the whole herd after interest. We've also improved our weaning rate, which has gone from 50% to 64%. We are able to mate less breeders, but wean a similar number of calves, which has improved our reproductive efficiency. So that is interesting, but we could also do some break-even analysis for the supplementation cost. How much could we spend per head before it isn't worth it anymore? So we could trial and error this increase until we get the exact cost where we have the same gross margin as we currently do prior to supplementation, which is shown in scenario 3, meaning our production gains from the supplementation is offsetting the cost. Again, I'm going to save you watching me test all the numbers, and let's look at what happens when we feed it at $83 per head per year. Press calculate. You will see now that our gross margin for the herd after interest is now the same before and after supplementation at this cost. So supplementing at $83 caused our variable cost to increase to $196,000 for the herd. So this $83 is what you would be able to spend up to in this scenario before your production gains offset the costs and it is no longer worthwhile from a profitability perspective. If we were paying the break-even cost for the supplementation, physically we're still getting the live weight gain and the other improvements, but it just doesn't pay to have them when the phosphorus is that expensive to feed. So that's really interesting break-even analysis that you can derive from this tool. For our final management strategy, we're going to look at destocking for grazing land management. Firstly, I will run through the land condition input in Breedcow Lite to show its function. Then I will model destocking by 15%, with and without a subsequent improvement in land condition. Grazing land management is a really important strategic decision for graziers as they have scarce natural resources and we need to utilise them to their sustainable potential. Back to start, we'll take our scenario 5 and place it back in scenario 1. So for this base scenario, we've optimised our preg-tested empty sales at 100%. We're going to feed wet season P back at $15, and we're going to calculate that so that we have a base file for comparison and analysis. For scenario 2, we're going to assume that this property's stocking rate is still too high. We're assuming that the level of grazing is not sustainable over the long term if we're trying to maintain or improve our land condition. If we change our land condition from a B to a C, you can see that it has dropped our adult equivalents automatically. That is a percentage reduction based on research which you can read more about on Future Beef through this link. However, you can overwrite the calculated adult equivalent reduction. So let's try destocking by only 15%, bringing our number of AEs back to 1020. Press calculate as is. So this is the destocking by 15% with no modelled improvement in land condition. So what's important to note from these results is that our gross margin per adult equivalent remains exactly the same at $179. The effect of the reduced capacity of the land can be seen in the herd gross margin. You can see there that it has dropped by about $32,000. This is due to the total herd number reducing. Okay, so that's interesting, but what is likely to happen over the long term is an improvement in our cattle production due to improved land condition. So with our reduced stocking rate of 15%, we've been able to put rest into our pastures, improve our body of feed to better meet the needs of our reduced numbers. So let's tweak our cattle production numbers. Our live weight gain, let's bump that up to 145 kilos. And our calf loss, let's reduce that down to 7% and press calculate. Now you can see there that the gross margin per adult equivalent has gone up and our gross margin for the herd is about the same. So we've reduced our numbers by 15%, got a bump in our live weight gain and reduced our calf loss, which has resulted in us producing beef more efficiently, which you can see there in our kilos of beef per adult equivalent and our weaning rate. So we've just completed strategic analysis of 3 management options using Breedcow Lite. In the next videos, we will be digging deeper into the software, the background assumptions, the theory, and the definitions. Feel free to reach out to our email if we can assist with using the tool.